Welcome to Daily Papers, the podcast where we break down the latest fascinating research into bite-sized conversations.
Today, we've got a really cool one. Imagine you're an AI model, a big one. You've basically read the entire internet, every Wikipedia article, every book, every blog post. What's next? How do you get any smarter if you've already consumed all of our data?
It's a huge problem in AI right now, sometimes called benchmark exhaustion. We're running out of new things to teach these models. But a paper from researchers at Amazon titled NanoFlux proposes a really clever and, frankly, fun solution.
It's fun because their solution is basically to create an AI fight club.
Exactly. Instead of just finding more data for an AI to read, they make AIs challenge each other. The system, NanoFlux, uses 3 different large language models, or LLMs. Think of them as 3 different AI brains. They have different jobs.
You've got the attacker, the defender, and the judge.
The attacker's only goal is to create a new, super difficult question that it thinks another AI will fail to answer. It does this by taking concepts from a few existing questions and weaving them together into a tricky, multi-step problem.
So it's not just pulling a hard question from a textbook, it's inventing a new kind of challenge. Then that question is given to the defender. The defender's job is, you guessed it, to try and solve the problem. But to keep everyone honest, there's a third AI, the judge. The judge first looks at the question from the attacker and makes sure it's a fair, solvable question, and that the attacker's own answer is correct. Then, after the defender gives its answer, the judge evaluates it, checking the reasoning and the final result.
This whole setup is what researchers call an adversarial framework. The attacker and defender are adversaries, constantly pushing each other to their limits. It's like a genius creating a puzzle for another genius with a grandmaster referee watching over them.
But here is the most important part of the whole process. The researchers aren't interested in the questions the defender gets right. They're looking for the failures.
That's the gold mine. The questions that the defender gets wrong are the ones that perfectly target that AI's specific weaknesses. It's like finding the exact blind spots in its knowledge or reasoning.
So the NanoFlux system runs the cycle over and over, collecting a small, very special data set made up of only these ultra-hard questions that stumped a powerful AI. And when I say small, I mean small. For each subject, like math, medical reasoning, or genomics, they only collected 200 examples.
200. For context, models are usually trained on datasets with millions of examples. So what happens when you take these 200 super targeted questions and use them for training?
That's where it gets wild. They took a medium-sized AI model and trained it on just these 200 questions. This process is called fine-tuning, which is just giving an already trained AI some extra specialized practice. The results were astounding.
Let's talk numbers. In medical reasoning, the model's performance jumped by over 16%. That is a massive leap. In challenging math and scientific reasoning, it improved by about 4 to 6%, which is still a huge deal.
What's more, this tiny dataset of 200 questions made the model better than if it had been trained on the entire massive original benchmark dataset. It's the ultimate proof of quality over quantity.
And think of the efficiency. It took 3 to 14 times less computing power to train the model this way. That saves time, energy, and money. It's like discovering you can become a world-class athlete by doing 20 perfect, targeted exercises instead of just running aimlessly for thousands of miles.
But the paper digs even deeper and uncovers some really counterintuitive things about how AIs learn. They did what were called ablation studies, where you tweak different parts of the experiment to see what really matters.
And they found there's a sweet spot for how hard the training questions should be. You'd think that the more complex the question, the better it is for training, right? Throw the hardest possible thing at it.
That's what I would have thought, but it's not true. For math and science, questions that were made from a smaller number of seed concepts, so moderately difficult, actually produced better results. If the questions got too convoluted, the model's performance actually went down.
It's like the super complex questions just introduced noise and confused the model rather than teaching it a core principle. The story was a bit different from medicine, where integrating lots of different information is key. So slightly more complex questions were better, but even there was a point where it became too much.
They found a similar sweet spot for the quality of the answers too. The judge AI rated all the reasoning on a scale from 1 to 5. Level 5 was a perfect, concise, elegant answer, the kind of thing a professor would write.
And you would absolutely think you want to train your AI on those perfect L5 answers. Give it the best of the best.
But again, no. The best results came from training the model on level 4 answers. These were answers that were correct and well-reasoned, but maybe a little more explanatory. Maybe they explored a dead end for a second or included more detailed steps.
So the slightly less than perfect but more detailed reasoning was a better teacher. It's like the AI learns more from seeing the messy thought process than it does from just seeing the polished final proof.
That is just fascinating.
It really is. It tells us that the best way to teach these models isn't just to show them perfect examples, but to show them rich, detailed reasoning that exposes the how and the why of a problem.
So the big takeaway from NanoFlux is pretty clear. The future of making AI smarter is probably not about finding more and more data to throw at them. It's about being incredibly smart and strategic about how we create that data.
It's about creating these adversarial setups, these AI fight clubs to automatically find a model's weaknesses and generate the perfect, tiny set of problems that will make it learn most efficiently. Less data, but the right data, is exponentially more powerful.
A small dose of poison to build up immunity, a targeted workout to build a specific muscle, a brilliant adversarial approach to building better AI.
And on that note, that's all the time we have for today. Thanks for tuning in to Daily Papers.